We're going to start with descriptive and exploratory analysis of this contraceptive use data that was introduced in the lecture. So the learning objectives for this lab, you're going to learn to define tidy data, a concept that has become influential in the R data analysis world. You'll load a data set into R, perform some basic exploratory data analysis, including the descriptive table 1 data, the epi table 1, and a customized bar plot using ggplot2. These are the exercises. I won't go through them right now, but I'm just going to talk a little bit more about these data now. They're the distribution of 1,607 currently married and fecund women interviewed in this Fiji fertility study. And they're recorded their age, education level, and desire for more children, as well as their current use of contraception. So in the lecture, I just used the base R for reading, and I demonstrate here using the read R package, which I'm a big fan of. It has a lot of advantages for reading data sets, both if there is anything difficult about them, and for problematic data sets in any way. This is the code that I use to produce the notes that you see. I'm just going to show you a little bit what it looks like. I'm going to do File, Import Dataset from Text, Read R, Browse. Let's see, session 2. Here we are, cues.dat. So by default, it doesn't know what the .dat extension is, and so everything is just one column here, and I have to play a little bit here. So the guess was comma delimiter. That's not the case. I don't know, it could be a tab. Nope, that didn't help. White space. Yes, that did the trick. And you see here this that we have this extraneous sixth column. That's because you can't even see it if you look at this data set, but there are some extra spaces at the end of some of them. So it's a little bit of a problematic data set. It's handled elegantly by the readr package here. And we don't have to do anything except say I don't want it. So I'm just going to skip this. Now there are a couple of numeric columns. I'm gonna, let's see, they're set as double. I'm gonna turn them into integer just because they are actually counts. So a nice thing about doing your import this way is that you get to actually check that things are being imported as you want. And the character things are imported as character as opposed to factors, which are useful in data analysis because they encode some extra. Well, they're useful for regression because factors also encode within them what the baseline level is. So I'm going to turn these to factor. readr makes me do a bit of work here, though. I actually have to manually say what the values are. So I'm going to say that no and yes are the values of once more. So it actually explicitly codes that. And then for education, let's see, it's low and high. And let's see, the typing gets a little bit annoying for age, but see if I can get them all on the screen here just so that I can see them. There's less than 25, 25. Okay, I think I can get them all now. At least you only have to do this once. It's an intentional design decision by them to make you do this manually as a way of avoiding mistakes. So let's see, there was less than 25. Oh, I can't see them anymore. I'm going to cancel, and I'm going to let's see, how can I do this? I'm going to write them down. There's less than 25, 25 to 29. You could paste these into anywhere, just a place to put them. I'll show you. You don't have to do this either. I could leave these as a character and then convert them after entering them. It would be a little bit less work up front. But I kind of like doing this. It makes it explicit what you want and easy to control it, even if it's a bit of extra work. So there's my comma separated list of factors. I'm going to copy my code just so I have it, and there we are. Looks good. So, let's see, I need to get, just to show you what I got, here's Q's. If I type levels of education, of Q's $education, I see low and then high. This is something kind of convenient because I entered them manually, that low is coming before high. I did that intentionally just because, do you know what the default is if you convert, if I, let's see, go factor, C, low, high. The levels are high and then low. It's just alphabetical. So if I had just done this automatically using base R or just using factor, I would have had high education as my baseline level. And maybe that's fine, but it's kind of annoying having this just be chosen for you alphabetically as opposed to setting it yourself when you read the data. There is a relevel command that allows you to change the levels, but why do that if you can just set them right the first time? Let me see, question mark relevel I think is the command. Yep, relevel X and ref. Okay, so let's see, oh, how do I get back here now? I need to, there we are, I did Control Shift 1, Control Shift 2. So if I had this and then I did relevel ref equals low, then I get back to low being the reference level. So that's perfectly fine to do as long as these are what you want them to be. So in this case, my reference level is low, and in this case, when I read it, the reference level was low as well because I specified that first in my comma separated list. Okay. So we've got our data set in now. I'm just going to go back to showing all panes here. That was under view. It's a little easier because I'm going back and forth a bit between the code window and the output window. Oh, when I reran this code above, I got an error that happens sometimes if you're not using readr. I was just running the code. If your RSet console is not in the same directory as your source file location. So if I did get working directory, it's in session 2, but this is in the session 2 vignettes directory. So you can fix that by going sessions, set working directory to source file location. And now if I run this, Command Option C on my Mac, it actually runs. Okay, first thing, the epi table 1. You make this for every assignment, every paper that you write in epidemiology. This is a nice package. The table 1 package has a function called create table 1. It has lots of customizations to help you make nice epi table 1s. I'm just using it here with the default data to produce a table that looks like this. And this is your standard table that summarizes the characteristics of your cohort. So it summarizes for me the number of, well, this is not the number of participants. This is the overall number of, let's say, levels, because we actually had counts in there. We would have to do some transformation of this data to actually produce a correct table 1. And maybe I'll leave that for now. I actually didn't think of that when I wrote this the first time down, but you'll see in the next exercise, I do some work of transforming the data. Maybe it would be great if someone does this during the week so we can talk about how to do it to get the correct actual number of participants here. So I mentioned this thing, tidy data, and I mention it now because we're going to have to do some reshaping of this data set for plotting it with ggplot2. This is the closest what you might call a seminal paper in data science, and it's interesting because it is actually a paper that is just about data and the representation of data. And it starts with this quote that happy families are all alike. Every unhappy family is unhappy in its own way, which I've heard used in all sorts of contexts, but it's especially appropriate for this paper because its entire premise is that there's only one way for a data frame to be tidy and lots of ways for it to be so-called messy. In order for it to be tidy, every variable forms a column, each observation forms a row. So you can see already this is not a tidy data frame because we have counts of the number of observations in a row. We would actually have to make it much longer. So there were, I think, 1,600 some participants. It would have 1,600 some observations as a tidy data frame. And then finally, each type of observational unit forms a table. So in this case, the observational unit is one woman who was interviewed and asked whether she wanted children, more children or not. If we perform some other kind of observational unit, such as something about the clinics where they were interviewed, data where each observation is a clinic, that would form a different table. So it doesn't mean that you can't then change them. In fact, there's discussion in the paper about how for many analyses you have these tidy data frames in separate tables, and you have to join them in order to do analyses. And so in that example of data on each woman and data on each clinic, if you were then going to do some hierarchical data analysis involving both, you would have to join them. But the so-called tidyverse and dplyr here has tools that make it very easy to do things like that. If your data are in a tidy format, they make it easy for you to do any kind of thing you might want to do with it. And messy data, according to Hadley Wickham, is any other arrangement of the data. So now let's do some work on the data to get it in shape for plotting. I'm going to start by grouping by age. So just taking a look again at what we had. We have 4 rows for every age here. So I'm using, these are tools, part of the Tidyverse, but they're from the dplyr package that expressively do things like this. It's formed up of verbs that describe what you want to do. So I want to group the cues data set by age and wants more. So that means that any rows that have the same value of age and wants more, I'm going to group them together. And then among those groups, I'm going to create a new variable that is the sum of the using variable of the using variable, and a new column called not using that is the sum of the not using variable. So let's see what that looks like. So now each row has a unique value combination of age and wants more. And now instead of the using column that we had before, they've been summed. So let's see, what did we have before? We had also education. So I've gotten rid of education here and just summed up high and low education together. That's just for the purpose of this bar plot, because I didn't want to plot education. So now I'm going to do something called a pivot. I'm going to pivot this into a longer data frame because I need, these are both counts, and I want the counts to all be in the same column. So in this pivot longer, there's several ways to define which columns I want. The colon says everything from the using column to the not using column, and anything in between, but there's nothing in between here. So I'm going to take these columns and the values I'm going to put in a new column called N, and then I'm going to make a new column called contraceptive that has these values, using and not using. So what does that look like? There, now I have this longer data frame with counts and using, not using. So also, if we were going to do a logistic regression, this is more the format that we would need, although we would need obviously both the using and not using. Sorry, actually we have using, not using. We could use this for a logistic regression. So now I'm going to create the bar plot, and I did a lot of customization for this bar plot. I spent a little while. It's easy with making plots to spend some time on it. You can make a very simple bar plot just very quickly. Like if I did ggplot, and most of you have now taken that primer, the data visualization R primer that explained to you basic usage of ggplot. You can do that with a geom bar like this and get a decent bar plot. Try it out. But I added a number of things. So what I did with weight here, it tells me that I want the height of the bars to be n, and then this fill is going to help me to create a stacked bar plot. So I'm going to be filling them with the contraceptive values. And then this facet grid is kind of a fancy thing. It creates a multi-panel plot. So this tells me that I want to create a panel for each age. Notice I'm using a model formula here. It's actually possible to create multi-dimensional facets with more than one variable. I'm just going to use age here, and it's going to create a 1 row by 4 column grid. And with this labeler, you'll see what it does, but I want it to show it, to give the column name and the age to make them clearly labeled. Then just some stuff. This is stuff you need to do for your assignments too. You need to add labels. The title is kind of not necessary. You can title things with the caption, but also the subtitle is not unnecessary. What's really necessary here is the X label and the Y label. I'm making this a black and white plot, so let's see what it looks like. I need to give some room back to the plot window here. There we go. It took a bit of time, but I have this nice looking plot with an X label, a Y label, and you can see the facet grid here. So there's age less than 25, age 25 to 29, the 4 age groups, and in each one I've put side by side. So this is just a regular bar plot function because I put X as wants more children. You see the fill of contraceptive here, so the gray is using contraceptive and the white is not using contraceptive. A nice bar plot. And then I demonstrate here, actually, this is kind of the boring stuff, but captions are important. And I have kind of a bit of a format for writing a caption that I recommend. And you'll notice when you go to do the first assignment, I do want you to write a caption for your figure, also for the table. So just to take a look at the table, where was that? Tables can have a very short caption like this. Table 1, characteristics of the contraceptive use data set. Figures, because tables are fairly easy to interpret usually, or there's not much that you need to analyze and interpret about them. But figures are diverse and complex, and so they need more of a caption. So what I recommend is start with figure 1 and a title, and then go ahead and explain the figure. So anything that is not completely obvious, go ahead and explain it here. Like the bar plot is organized by age, group, and stacked by self-report of whether a participant wants more children. And then it starts to provide some interpretation here. The fraction of women wanting more children decreases with age, becoming a minority in the 40 to 49 age group. One unexpected observation is that in the less than 25 age group, those reporting wanting more children appear more likely to report using contraceptives. Why did I say that? Let's see. View, let's show the plot. So it's hard to tell here. So it looks like among those who do not want more children, it's, I don't know, maybe 20%. And among those who do want more children, it's hard to say. So I actually made an exercise for you here that you could make this more visually clear by using percentages, so that each of these came up to 100% instead of numbers of counts. So I leave that for an exercise for you. I gave you some code to calculate the percentages by taking this data frame Qs by age, grouping it by age, and then mutate creates a new column. I create a new column called percent, that is the sum divided by the total sum of n times 100. So if you calculate this and then just go back, maybe copy this code block down here, and instead of weight equals n, use weight equals percent, you'll get another plot with all of these going up to 100%. So that's all. Go ahead and try this. You can use RStudio Cloud. You can use your own laptop, and let us know if you enjoy it, if you have troubles. It's a challenging first lab, but I think you'll learn a lot through doing it, and you'll, by the time you do this lab, have most of what you need for doing your first assignment in terms of skills. All right, thank you.